Hi guys. Okay, so let's look at the questions on chapter 6, and that is regarding the shapes. So for Chem 30A, these are smaller shapes, just linear, trigonal, planar, tetrahedral, like the simple ones. Okay, so the linear shape is this, like a line, a linear, very simple. So there are 3 atoms, right? And it's very symmetrical molecule. So that's linear shape. Next is the trigonal planar. Now that is like a flat, like a triangle. Okay, planar, flat, triangle. So that's the triangle. Next is the, this one is a bent shape, bent shape also. Bent shape. And bent is like if there is a lone pair somewhere on the top in the central atom, then it bends, the VSEPR theory, it bends the bonded atoms. So the lone pair can occupy its own space on the top. So a bent molecule would look like this. And a tetrahedral looks like this. It's like a 3-legged chair. So the 3 legs are on the bottom, you see, and then the top is the, like the back of the chair. And the black piece you see is like where you seat. Okay, that's a seat. So that's a 3-legged chair. So one side facing you, one side on the side, one side at the back, and one side is at the top. Okay, then there is a trigonal pyramidal also, like a pyramid shape. So in this case, there is a lone pair on the central atom, but the 3 sides are like a triangle at the base, but lone pair on the top. So just like a pyramid shape, okay? So we see now there are 2 types of shapes discussed in this table. One is the electron group geometry. The electron group geometry is internal. It's an internal shape. So just keep that in mind. Next is the molecular shape. Molecular shape is external. How does it look to you? So for you guys, molecular shape for Chem 30A. Chem 30A, look at the molecular shape. If the question does not even specify, it's always molecular shape. So this table is in your book, as well as I put this on your handout also. Now, another concept is about the electron groups. Now, electron groups, this number is with respect to the central atom. How many groups are there on the central atom, right? That if there are 2 groups on the central atom, electron groups, electron clouds, then the shape would be linear. But if there are 3, then it can be like a bent, or it can be like a trigonal planar, those things. So we will discuss this. So this is the electron group geometry though. Okay. Next is the tetrahedral shape. So if there are 4 electron groups, tetrahedral shape. Okay. Now, that's one piece. Now, I also have this big table here. Big table is like there are more types of shape, like trigonal pyramid, like bent, trigonal bipyramidal, a seesaw shape, T-shape, linear shape, octahedral, square pyramid, okay, square planar, all these. So these shapes are also present, but in more complex molecules. So I put this table, you can refer to this also. Same thing, this is the ion and molecular type. A stands for, it becomes easy to do it. A stands for the central atom, X stands for the outer atom, and E stands for the electron group. Electrons, the lone pairs on the central atom. Okay, the lone pair on the central atom is the E. So X is the outer atom and A is the central atom. Okay, so if there are like 4, let's say if there are 3 lone pairs on the central atom, then it becomes E3. If there are 2 bonded atoms, it's X2, and A is the central atom. Okay, so you see that there are 5 electron groups. No, sorry, there are 5 atoms bonded to the central atom, and there is 1 lone pair on the central atom. So this is one piece. Next thing is the shapes. Now also you need to know how many bonding electrons groups and how many non-bonding electron groups. That is important. Non-bonding are the lone pairs on the central atom. Okay, non-bonding are the lone pairs on the central atom. Bonding are the bonded atoms. Okay, once you know the bonded atoms and the lone pair on the central atoms, then you can just match with the with these shapes. Okay, so that same thing here also. In this table also, these molecular shape, bond angles, lone pairs. So electron group geometry is it. So look at the bonded atoms and the lone pairs. So these are the two things that you need to see. Bonded atoms, how many atoms are bonded to the central atom, and how many lone pairs are there on the central atom. So the main thing here is the central atom, the main thing. Main theme here, which defines the shape. Okay, so now let's look at the shape of this one molecule that I'm going to do for you. It's carbon tetrachloride. Okay, so first thing, always, whenever they're asking you to do the shape, although the question is not asking you, always draw the Lewis structure, because without that, you cannot. Always draw the Lewis structures. Okay, now, so same story we are going to do. Carbon, 4 valence electrons. Chlorines, 7 valence electrons. And there are 4 chlorines. So, and there is only 1 carbon. So we have 4 plus 7 for the 28. So a total of 32 electrons. Okay, 32 total valence electrons. Carbon can make 4 bonds. And chlorine can make 1 bond. And yes, chlorine can make more bonds, but carbon is less electronegative than chlorine. Therefore, carbon is going to be in the center. And it can also make is a central atom. Okay, so this is how you identify that. So don't get confused. Now we are going to make this. So here we have carbon 1, 2, 3, and 4. Do not put this at 90 degrees. Do not put this at 90 degrees. Okay, that's one thing I'm just, so we'll make this by default, because in 3D, there's more space than just 90 degrees. It's more squished at 90 degrees. Okay, so now how many electrons did we use? We use 1, 2, 3, 4, 5, 6, 7, and 8. So 32 minus 8, what do you get? How much? 12 minus 8, 4, 14, 24. 24 electrons are left. Okay. Yeah, 24 electrons are left. So where are they going to go? On the central atom, on the outside now. So 1, 2, 3, 4. So these go on the outside. 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So all 24 electrons have got used up. Okay, so always draw the Lewis structures. Now, count the valence electrons and total, and then see if the octets are met. So look at this carbon and chlorine. 1, 2, 3, 4, 5, 6, and 7, 8. So the chlorine's octet is met. This chlorine also 1, 2, 3, 4, 5, 6, 7, 8. Octet met. This one also 1, 2, 3, 4, 5, 6, 7, 8. Octet met. 1, 2, 3, 4, 5, 6, 7, 8. Octets are met. Okay. So octet is met. Octet is met for each one. Carbon also, the octet is met. So this is a valid structure. And if you count the electrons, they're all coming out to be 32. But we have to look at the shape now. Once we talk about the shape. So you see the central atom, carbon. So around the carbon, how many bonded atoms are there? Bonded. The bonded atoms are chlorines. And there are 4 chlorines. Okay. And is there any non-bonded? Non-bonded, like electron group. So in other words, lone pairs. There are 0 lone pairs. So 0 lone pairs. So what does it correspond to? Let's look at this. So it corresponds to so there are 4 electron groups, that's for sure. So out of these 4 choices, which one applies to us? So we do not have a lone pair. 0 stands for the lone pair, okay? 4 stands for the bonded atoms. So the shape is tetrahedral, and each of the carbons is, and each of the chlorines is at 109 degrees. So shape is this corresponds to the tetrahedral shape. So once you identify the shape, you really need to draw it that way, okay? So here you will see you have carbon in the middle, and you can make like a wedge shape like this. Here, hydrogen, you can make like this type of wedge. This here, this thing is at the back. This hydrogen is at the back, and this is the back of the chair. Okay, so this is how you're going to show the tetrahedral shape. This is important. That's what I'm saying. You know, some of these, this is important. So it looks like a test question, and this might show up on the test. So yeah, if I don't see it drawn like that, then I can't give you the points. Okay, so just make sure that you do it this way. Next is tell whether this molecule is polar or non-polar. Same thing again. You, even though the question is not asking you, but to solve this problem, you have to draw the Lewis structures so that you can see. Okay, so here you have carbon, one carbon, one hydrogen, and then you have 3 fluorines. Okay, so one carbon has 4 electrons, one hydrogen is 1 electron, and fluorines have 7 electrons. So how many you get? You have 4 plus 1 plus 7 3s are 21. So how much? 26 electrons. Okay, so same thing, carbon can make 4 bonds, and hydrogen makes 1 bond, and fluorine makes 1 bond. So carbon gets the center spot. Okay, central atom. Carbon is a central atom. So you draw carbon here. Now, which side to put what? So let's put hydrogen just for the sake of symmetry, and the fluorines on the other side. Okay, this side. Now, you're going to connect them with a single bond. So single bond uses 1, 2, 3, 4, 5, 6. So 26 minus 6 electrons, and you're left with 20 electrons. So where are you going to put the 20? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, sorry, I didn't connect that. I should have. I made a mistake here. Sorry. Wait a minute. I forgot that one. 1, 2, 3, 4, 5, 6, 7, 8. So this should be ideally 8 electrons. Okay. So then you are left with, this one is 18. 18 electrons. Okay. So we see here, we don't do, because hydrogen, keep this in mind, does not follow the octet. So this is the reason why I did it on hydrogen, okay? On the top, like I didn't do it on hydrogen. Started with fluorines, filled those up first, okay? So now you see hydrogen only needs 2 electrons, and hydrogen is getting 2 electrons. Each of the fluorines have 8 octet, you know, the bonded ones are octets, and then hydrogen is just, so we see that the octet of carbon is met, octet of hydrogen is met, so the octet of carbon and hydrogen, all of them are met. So 8 electrons of carbon and 3 fluorines, right? So that's all met, happy state. Carbon wants to make 4 bonds, right? Always important to check. Carbon wants to make 4 bonds. It's making 4 bonds. Fluorine, only 1 bond, and fluorine is also making 1 bond. So this is a good structure, okay? Now, the only thing is now they're asking us the overall like polarity in this molecule. Is this molecule polar or non? So polar molecule or non-polar molecule or non-polar. So when we say polar and non-polar, what do we see now? We are going to look at the individual bonds. So let's look at this. So hydrogen, leave that on top. Carbon, let's just bring this here. Fluorine. Okay, now, if you look at the electronegativity values of fluorine and carbon and hydrogen. So these are the bonds, right? So let's do this here. Carbon and hydrogen. Okay, now electronegativity values. So here are the electronegativity values of fluorine, 4.0, and carbon is 2.5, and hydrogen is 2.1. So let's write this down. 4.0 and carbon 2.5, 2.1 and 2.5. Okay, subtract. So the difference in electronegativity, 4.0 minus 2.5, 1.5. And here 2.5 minus, so this is 0.4. Okay, so fluorine is a highly electronegative, is more electronegative than carbon. So fluorine, so look at that. If the difference in electronegativity between fluorine and carbon. So we see this here, that the difference in electronegativity between fluorine and carbon comes out to be 1.5. So this is a polar bond. That means unequal sharing. That means there is going to be that is a polar bond. And so there is going to be a charge, okay? Delta positive. And then carbon and nitrogen have 0.4, like it's right at the border, carbon and hydrogen. So it's right at the border. So we can consider it as, generally it's considered as non-polar, okay? So now let's look at this here. So this becomes polar. And this is, we'll place this because it's at the border. So it's non-polar. Okay, not as polar as this. So fluorines, delta negative, delta negative, delta negative, and hydrogen is delta positive. Carbon is kind of in between. So, right. So here, this is a non-polar bond. Obviously, we see that. And each of these bonds are polar bonds. Polar bonds. Okay. So one side is polar. The other side is non-polar. So definitely this molecule is like overall polarity is, so let me draw this again because I just wanted to show you guys. So F, F, and F. So overall polarity is towards the fluorine side. Okay, the net polarity. So this overall becomes a polar molecule. So this is how you are going to identify. Okay, this is how you will identify molecule. Okay, overall polarity of the molecule. So first you have to look at the individual bonds, and then you see, like, sometimes remember that it's not the individual bonds may be polar, but it is an unsymmetrical molecule, and unsymmetrical molecules polar. Okay, all right. So let's stop here. We're going to go look at the intermolecular forces in the next video. All right. Okay.